Hey guys, welcome back to my channel. I have another video here. This is another repair. This is from a 2005 GMC Yukon SLT. Customer complaint is that the cluster prindle light is very dim, or actually you can like not see it. The rest is working fine. So I'm about to take it apart and take a look and see what I find. So I already removed the front cover. No, this is the part. It's just, clips, plastic clips that you have to open up. The cluster removal is pretty simple. You just remove the cover on the car, which is in front of the cluster, and then it's for 7 millimeter bolts and disconnect in the back. So that's a part that I didn't want to show. So the needles are just a little careful. I mean, some people like to mark and put tape here and put the exact location. The actual needle will not go down more. So all you got to be careful is to make sure that the needle sits to the maximum whenever you put them. And it's usually like an eighth of an inch from the zero on the cluster to where the needle really sits when no power is, because as soon as you put power, the needle will go up and down and will stay like in zero. So just be careful with that. But I mean, I have done this many times and it's not an issue. In order to remove the needles, just be careful. I'm using a tweezer for this. You have to be, especially with these long ones, try to like pry with something. I don't want to mark the cluster itself, but I need to keep something steady on that side. These ones are the hardest ones to remove. And that's it. So just, I like to put this on a position to like put it back to where it was. I mean, these two are pretty much the same length. As you can see, so the RPM and the mileage are the same, and the rest of the needles in here are all the same. So, like the temperature and oil pressure and so on. So let's remove this last one. All right. So I'm going to take this apart now that we have all the needles out. We have a little bit of a plastic holding the actual face. Again, you have to be careful with that. Let's see what I can take out. Somebody was trying to call me, so that's why that video stop is there. So all you gotta do in there, again, to remove this is just make sure tweezers work perfectly in here. And now we got this out. I'm gonna put them on the side. This plastic should come off with no issues, hopefully. Okay, we got this off too. And I'm using these glasses because it's not really so bad yet. Trying to see if I find something that I can see specifically. Otherwise, I'm gonna have to use the actual microscope. Yeah, but this one I don't see much damage in here. I think if I take it from the back, it's gonna give me, make sure nothing falls. Sorry guys, if you're not looking at that, all I'm doing is actually the same thing on the back cover. All you gotta do is pop this open and the cluster is going to come apart. Now we have this plastic that is in my way. I'm gonna use a small flathead to get those out. Okay, we got the other portion out, and the cluster is truly just being held in here by nothing, as you can see. So this is probably the best way. I can put this away, and I can now work with my microscope. Put these glasses away. Let me stop the video, set you guys up into the screen, and like that I can use the microscope. So 1 second. Okay, I got the cluster under the microscope and immediately found one of the resistors that is the most common. Let me set the camera so it's perfectly crystal clear for you guys. Ugh, that's not good. Let me set you guys back again. Okay, that's a very good look. Try to turn the camera so you guys see exactly the same thing as I am. All right, so usually the resistors that are giving the promise is because the soldering comes off. So right here, right where my tweezer is, as you will see, this edge right here is off. Like this one is looking good, but this one and this one, the solder by temperature has separated. So let me do a closer look. Yeah, definitely, 100%. Yep, microscope is just the best. Let me move this a little bit. Let's see if I can put another light. You guys can see better. Is that helping? Not really much, right? Yeah, this microscope has a very strong light. I'm again a little off focus for you guys. That is the perfect look. Perfect look. All right, again, I get the tweezer close. So definitely that completely resistor is cracked. This is, as you can see, I just left it. So, yep, that resistor is completely off. So that's what we're looking for. It's just soldering joints cracked by temperature and, I was at 2005, so we're talking about, what, 13 years old? So it's not too bad. So let me, probably that's a better capture for you guys. I can see the whole resistor and actually another one on the side complete, but not in the camera, right? Okay, so let me put so you guys can see what I will be doing again. I'm gonna turn the micro tip. I use for this one the Hako Station FM 203. With this one, I can use the tweezers and the micro tip or micro pencil to do all these repairs. As usual, before you do any repair on this, put some flux. Very important. You guys saw that, right? How I moved. And this one is the same way. So I'm going to correct all these joints. Not sure if you can see the other resistor, but yeah, definitely. So I have to put a little bit of a less. So what you look for, because usually this solder on these boards is it has a higher temperature for melting. So what you do is, like I'm doing, I'm putting a little bit of the lower temperature solder on the tip of this pencil, so I can make a mix and lower the actual temperature to get this resistor out. Actually, might not need to get it out. It looks pretty good in there. Yeah, that actually worked out very well. Hopefully you guys can see that. I mean, I can use a tweezer for this, which is going to heat up both sides of the resistor, but this one is working very well. Let me get more soldered on that tip for the next one, which is also bad. Yeah, this one is definitely not good. This is all you want to do. I mean, resistors are fine. It's just cracked joints. And this one has enough temperature to melt those. I'm putting them in 750. I think it's 750 Fahrenheit. Otherwise it will be too much. Yeah, this one is cracked as well. Gonna need a little flux in here, most likely. Yeah. Put the micro pencil on the base like that. It goes to sleep instantly. And this is what you look for. I mean, usually these clusters are very good. This is the main issue they have. Let me clean this the tip of the pencil. Got a special chemical in here so I can clean that. Okay. Put a little bit more flux this time. And let's do the other side as well. You can see how the flux melts and I mean the bubbles. That's when you know that it has reached the right temperature. Yeah, all those joints are now looking very good. I sure went to sleep and it did. So that is one of the three that I just fixed. As you guys can see, it's perfectly soldered. That's all we need. Now let's take a look at these ones. You have to inspect very well this. Yeah, this one is it's not 100% cracked, but yeah, yep. So let's do all this one. Yeah, this one on this side. Hopefully you guys can see that in there. Yeah, all this. Yep, all these ones they gotta be fixed as well. That's why I didn't want it to clean too much, but well, either way. All right, so we need to do those. Let me see what else we got here, because I think those are for the lights, the one we just were looking at. Let's go on a quick inspection around. So I'm going to do the same thing on this other four. Just move the microscope a little bit out so I can have more room. All right, so let's get flux in here. Perfect. That is the micro pencil. When I remove it from the base, it tells me when it's ready to go. All right. Melt, melt, melt. Oof. You see how it was completely off on the other side. All right, gonna have to use well, actually, let me get the other side, change the composition. See, I didn't touch the side, so there's no way that this tip is going to move that one. So I'm gonna get the tweezers out now. Now the tweezers are hat. This is the best tool for this. You do both sides at the same time. I'm gonna need to put more flux into this one. And for some reason it's And I'm moving this side. Oh, it's not reading it. I got disconnected. That's why. Now it's ready to go. And for some reason it didn't read that I remove it. I was like, what the heck? It's not melting it. That's what this one is for. A little shaky today, huh? Now let's use the pencil this time. I like to use a pencil because you can go with a little bit of the flux and work on just one side. This one lift up, so it was impossible for me to do anything else. All right, so that should be good. Not sure, I think it's too far out. Let me get that tweezer and move it up. See, like it's too far up. I mean, too far down. I know you guys are not looking at the whole picture, but I need to be able to see what I'm doing. Yeah, this is hot. Gotta make sure it's in between the pots. Yeah, perfect. Yeah, now that looks better. All right, let me get out a little. What I don't need to be that close so you guys can see a little better what I'm doing. Again, micro pencil. And let's fix this joint so it don't look that cute. Better. And better. More flux in here. And let's do the next one. Yeah, you guys can see that one too. You can see by just doing this side, it's moving on the other side because it's cracked. Perfect. Let me move the board over so you can see better. Get a little bit more soldering or solder. Perfect. So all I'm doing right now is really just reflowing the solder. You see the other side is completely off. Yeah, perfect. And a little bit more because that side is slow. Sometimes it's hard to calculate where you are in the microscope. Yeah, that looks better. All right, so those will look good now. So we just did 4 7 resistors. They're all the same size. All right, guys, this is pretty much done. I reflow like another 3 or 4 resistors just to be careful or be sure. I had to stop the video here because my battery is about to die, but I will follow up tomorrow in the shop when I install this cluster back. So stay tuned.